Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and selamat sejahtera. Today we will present to you our mini project on a BKC 3543 microprocessor. Our mini project title is Pedestrian Traffic Light. And before we start, let me introduce our group members first. The first one is Muhammad Faizal bin Jamaluddin, Muhammad Hafizul Firdaus bin Abbas, Muhammad Subri bin Abdul Rahman, and me myself, Muhammad Faizal bin Abu Bakar. Before we continue, let's watch this video first.
Urban traffic management is a critical aspect of ensuring safety and efficiency on roadways, particularly and pedestrian crossing. Pedestrian traffic lights play a pivotal role in managing the flow of pedestrians and vehicles, thereby preventing accidents and ensuring the smooth movement of traffic. Assalamualaikum warahmatullahi wabarakatuh and good evening. I'm Muhammad Faizal bin Jamaluddin. Now, I will present to you about problem statement and objective of our mini project. Let's take a look on problem statement first. We have identified that the main problem is the absence of the practical and educational tools to simulate pedestrian traffic lights. This lack of a simulation system hinders both the training of traffic engineers and the public's understanding of pedestrian traffic lights operation. According to the World Health Organization (WHO), road traffic accidents are a leading cause of death worldwide. Now, let's go to the objective of this project. The first one is to design and simulate a pedestrian traffic light system using IDE 68K that accurately depicts the behavior of real-world traffic lights. Second, to designing the software logic to control the sequence of pedestrian traffic lights based on predetermined the intervals. And the third one is, of course, to gain practical experience in microprocessor programming and simulation techniques. Let's go to the next part.
This part is method and methodology. For method, we have Fila table. It provides a structured approach to our project, starting with facts, ideas, and then followed by learning process and action. And for methodology, we have coding, programming, and simulation. This methodology include with switch, 7-segment displays, and LEDs, which is connected to the IDE 68K microcontroller to enable their functionality. This is Fila table we use as a method for our project. As you can see, this Fila table have 4 approach. The first one is facts, then ideas, learning process, and conclude with action. The action step is to develop a pedestrian traffic light simulation using IDE 68K. Now we will move to next part, which is project demonstration. In this part, I will explain to you about programming or assembly language and simulation. As you can see here, this programming consists about 8 to 9 stages. The first one is peripheral, such as switch, LED, and 7 segments. And this is the address 3000, 4000, and 6000. The second one is select to compare the switch at condition 1 or 0. And then task 1, all LED is on which means the traffic light is still on red light, but timer is start counting, so the pedestrian will ready to cross the road. After that is task 2. All LED is off. This means traffic light has turned to green, so the pedestrian can cross the road. After that, task 3, all LEDs start to blink. This means a warning sign to pedestrian, so they have to move. They need to move faster before the traffic light turn to red. And then on task 4, all LED is on, which means the traffic light has turned to red. And that's all. We have a complete one cycle of pedestrian traffic light. Now let's move to simulation. Now we will start our simulation, but first we must assemble this programming to check whether there is an error or not. As you can see here, there is no error, so we can proceed to run Visual Simulator. But first we must select the peripheral that we have choose, which is switch, LED and 7 segment. Switch, LED and 7 segment. After that, we must go to configuration to match the address. As you can see, the address must be the address in assembly language must be same as configuration 3000, 4000 and 6000. Okay, now we'll start our simulation. 3 type of simulation, as you can see: single step, auto step, or run. So not to make this video too long, so we just go to run. Okay, as you can see, all LED is on. That means the traffic light is on the red light. So when someone comes and press the push button at traffic light on off, so the traffic light start counting to turn to green. So LED all off, so which means traffic light is green, and then start to blinking to give warning, to give a signal to pedestrian to move faster. After that, the LED will on, which means the traffic light is on the red light. So that's all to complete one cycle of pedestrian traffic light simulation. And finally, for conclusion, the first one is we're able to gain practical knowledge and skill in programming and simulation using IDE 68K. The second one is we're able to develop an assembly language code that would control the behavior of the traffic light system based on the state of a switch. The third one is managed to encounter challenges such as understanding the syntax and structure of assembly language, debugging logical errors, and optimizing the code for efficient execution. And last and foremost, rewarding experience, allowing us to apply the theoretical knowledge gained in the BEKC 3543 microprocessor course to a real-world scenario. That's all from us. Thank you very much. See you again.